Good morning. Numerical classes welcomes you. In the series of numerical problem, in the topic of transmission line, the second question that we are going to see is for an open wire overhead line, beta is equal to 0.04 radian per kilometer. Find the wavelength and velocity at a frequency of 1600 Hz. Hence, calculate the time taken by the wave to travel 90 km. So here beta is your phase constant. So phase constant beta is given. We need to find the wavelength and the velocity, and finally we need to calculate the time taken. So if we are seeing here in the question, your phase constant beta is given and the frequency is given. So if we are going for seeing the wavelength lambda is your 2 pi by beta. So 2 pi by beta, where beta is your phase constant. So just substituting the values of your 2 pi and beta it is given 0.04 radian per kilometer. If we are solving it, we are getting the answer as 157.079 kilometer. So this is the wavelength. Now next go for velocity. So velocity is equal to omega by beta. So here omega is your 2 pi f and beta is the phase constant. So in 2 pi f is the frequency. So frequency here it is given 1600 Hz. So just substituting the values of this frequency and the phase velocity beta, we can calculate this velocity. So we are getting 2 pi into 1600 divided by 0.04. So if we are solving this, we are getting 2.5132 into 10 to the power 5 kilometer per second. So the velocity is 2.5132 into 10 to the power 5 kilometer per second. So we have calculated the wavelength, we have found the velocity. Now we can find the time taken. So if we are going for finding the time taken, so we can say that the time taken is your distance by your velocity. So the question is calculate the time taken by the wave to travel 90 km. Distance 90 km is given. So just substituting the value of this distance in the problem. So distance is your 90 km and the velocity just now we have calculated, it is your 2.5132 into 10 to the power 5 kilometer per second. So if we are solving this, we are getting a 3.581 into 10 to the power minus 4 second. So hence this is the answer. So for this problem, first we need to calculate the wavelength, then velocity, and finally we need to calculate the time taken. Okay, thank you.